15. Where are you? Okay. I think if I just make sure I have the equations written down right, I can figure it out. I have 37.5 minus 40 divided by 12 divided by the square root of 36. Yep. I got negative 1.25.
Right.
Okay. And then I have 36.5 minus 40 divided by 12 divided by
36.5 minus 40?
Yep. Is that what I did wrong? Oh.
No. You did. Wait. Okay.
That's what I did wrong. It's 42.5, huh? I don't know where I got 36. Oh, from the one above.
The previous one, yeah.
Christmas. See, I need to be shocked. 32.5. Okay, I'll just go back to that because I can figure that out without wasting you guys your time. Okay. Now, go up. Close. Close. Michael, what's 1 and 2?
Right. Okay. So are you on number 3 now?
Yep.
Cool. So use the normal probability applet to find the combined area under the standard normal curve that is to the right of 1.385 and to the left of negative 1.385.
Okay.
Or 358, sorry. Okay.
So
Right.
5, 8.
Left. Negative.
Are we just supposed to highlight the two ends?
Yeah.
So 0.1745 or 0.175.
Right.
Where did... Uh-oh, I have to...
Go into the bathroom real quick. You wanna... Sorry. It's on.
What do you do? You on number 4 now?
No, because I did some... I lost my quiz, and so it took me out of it.
Uh-oh.
Okay, so 7, 4, 5. Okay. 1, 2, 4. One. Okay, yes, I am. Sorry. Can you read it?
Sure.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observation, the distribution of the sample mean. This cannot be determined from the information given. I believe it's this cannot be determined. But am I wrong?
I think usually the distribution of the sample means has a smaller standard deviation. Let me do something real quick. Please make sure. Oh. I did the same thing you did. I got the quiz. Hey, Shannon, we're on number 4.
Sorry, my husband got my ice
Four,
cream for me, and I have to eat it in front of
a
you
little bit. That's okay.
because it's melting. I'm so sorry. With 9 observations are randomly drawn from the population.
Yeah, okay, so this is our problem. Number 4.
Oh.
So, which standard deviation is going to be smaller if 9 observations are randomly drawn from the population? Distribution of the individual observations or the distribution of the sample? Or this cannot be.
So I'm not 100% positive, but when I was visualizing it, like the individual observations are the individual numbers, like X, like the individual ones. And so those could range anywhere from like outliers to far away.
Mm-hmm.
And so they're going to be really far away from the mean, but the distribution of the sample means would be closer to the mean.
Right. The standard deviation would be smaller of the sample mean.
Right. And that's just how I visualized it. I don't know if that's right, but I know the answer's right, but I don't know if I got it in the correct way.
The distribution of the individual observations.
Or the sample means the next one, the middle one.
The middle one.
Mm-hmm.
Each of the following will have a smaller standard deviation if 9 observations are randomly drawn from the population.
Does that make sense, Mindy?
Not really.
Yeah.
Yeah, I didn't really understand it either. I was just kind of picturing it as the sample means would be closer to the mean, so they wouldn't be as spread apart, to where the observations are just like all the random data, all the random numbers, and they could be spread everywhere.
Okay.
But I don't know if that's right. I know the answer's right, but I don't know if the way I got to it was right.
Okay.
Here's the little example, right? If you're pulling 2 from it, you have a better idea. See, it goes boom, boom, and then one falls in the middle. See it closer to the mean? It takes the mean of both of them, falls in the middle. Boom, boom, falls in the middle, so they're going to be closer to the mean.
Yeah, so Michael's got this little chart on his computer, and he's saying the same thing, that if you have the means, they're closer to the mean, not as far apart away. So I guess.
We'll go with that.
Okay, so number 5. Which of the following results implies that the spread in sample means, or whatever that X bar thing, decreases as the sample size increases? Let me read it one more time. Which of the following results implies that the spread decreases as the sample size increases? Pretty sure that is the law of large numbers.
Yeah, that's what I got too.
The increase of sample size to the more accurate. If the sample size is large, then the sample mean will typically be close to the population mean. This happens because the standard deviation will get smaller. Okay.
I know it's weird. It's weird because it doesn't say anything about spread in the definition, right? But basically.
But he talked about it in the movie, or the film, about this shape, size, and spread or something that didn't make any sense, but I know he talked about it. Okay. Use the following information to answer the next 4 questions. Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? Round your answer to 3 decimals. So do we do the Z equals X with a line over it minus?
I think it's just the normal Z-score.
Population means?
Yeah, so it doesn't give you the N or sample size, so you just do the normal Z-score formula.
I feel like
Okay. Mm-hmm.
1.4.
Well, what's our sample size?
You don't have one, and so you would use the regular Z-score formula.
The first Z-score formula. The easier one.
Right. What's the sample mean? Oh, the 105 or 150.8.
Yep.
No, okay. The easier one, though, is sample mean minus population mean, right?
Yeah, minus your mu. Yeah, the little P and U sign.
Yeah. So what's the sample mean?
No, it's not sample mean, it's just X. X minus sample mean, or X minus mean over standard deviation. Like the X without the bar on top, just an X.
It's just X.
It would be X minus the little U thing.
Right.
Over.
What is X?
X is your variable. So in this one, Diane earned a score of 160.
160 is the variable?
Yeah, because her score is 160.
Okay. Sorry.
Oh, you're good. Yeah, here you go. Mm-hmm.
114. 0.114. No, yes.
I got 0.045 or 1.045.
Okay. 160 minus 150.8 equals 9.2 divided by 8.8 equals 1.045. I don't know why I can't figure out the calculator, but okay. 1.045. Okay. Do you want to read 7?
Yes. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So we just found the z-score of 160. And I think...
Do we put that in the app because it's asking for probability?
Right, and we have to find out what is will score above it. So I have to make sure it's above
Above. So on the right.
it.
Bless you.
Thank you. So,
4, 5. Did you get 0.148?
yes.
Yay.
Now we're on number 8.
Yes.
A random sample of 5 students was selected to take the GRE. Their scores are, what is the z-score corresponding to the sample mean of these students' scores?
Okay.
I don't know. Do we add those?
Yeah, so it wants the sample mean. So
5.
yeah.
So we
So
add
just-
those and then divide it by 5?
Yep.
What?
160?
Yep. And then it says, what is the z-score for this sample mean?
Okay. So we do the Z formula.
And n equals 5.
Or we do the harder Z formula.
Yeah.
Okay. N equals 5. The mean is 160. So the sample size is what's the standard deviation?
8. The 8.8.
Yep.
How did you get that?
Is it 8.8?
Yeah.
Just from the information that it gives you.
In the beginning, it says use it for the next 4 questions.
Oh.
Yeah.
Okay. 28. So it's 160 minus 150.8 divided by 8.8 divided by the square root of 5.
Yep.
Okay.
I usually use Excel. See how I have the formula right here? So then, like when the next problem, we just change it.
Aren't you? Okay, so it's no.
Square root is square root is SQRT. You have to have parentheses for the first 160 to 158.
Hello?
Hey, you there?
Oh, yeah. Did you get 2.338?
Yes.
The reason I use this off just a little bit is because the sample mean, like the mean is like actually all that.
Okay. Are we on 9 now?
Yes.
What is the probability that 5 randomly selected students will have the mean score that is greater than the mean achieved by the students in the previous problem?
Wait. Sorry, I have to reread that.
That's okay. I didn't get it either. It says probability, so we need to use our applet.
Mm-hmm. So in the previous problem, the mean that we got was 160.
Okay.
So we'll plug that into the applet.
160. Wait, are we figuring out the greater than, so it's on the right?
The z-score was 2.338.
I'm lost.
So for number 9, it's asking you to plug in the applet, the answer that you got for number 8.
I didn't get 160.
Right. 160 is the mean, but the answer you got was 2.338, right?
Yes.
Okay, so that's the z-score, the 2.338, and you'll put that into the applet.
Oh. So what's the, you said, what do I do with the 160?
The one, nothing. It's just the way the wording is on the question.
Okay. I've got 0.0097, so it would be 0.010.
No, he said in this one to round it to 4 decimals, so just 0.0097.
Okay.
Yeah. Did you get the same thing?
That's what I got.
Woohoo.
Okay. Use the following information to answer the next 5 questions. Number 10. What is the shape of the sampling distribution of the random variable which represents the sample mean of the 81 students who are selected? Maybe I should read the information. Suppose the mean.
I don't know if that's going to help us, Michael.
Right. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. Okay. But even though it's left skewed, it's a big enough sample to where it's normally distributed. So
Approximately normal.
right. So what is the shape? Okay, so the shape would be approximately normal.
I would agree with approximately normal. I would almost agree with approximately normal.
There's a 0.5 chance I will agree. And then
I mostly, approximately, almost agree. Oh, gosh. Okay. Number 11. What is the mean of the distribution of the sample mean for all possible samples of size 81 that could be drawn from the parent population? Oh, goodness.
So this one is just making sure that you understand the formula. Mm-hmm. So they give you this in the suppose the mean of BYU Idaho students is 3.5. That's what it is, 3.5.
What? In 11?
Yeah, on 11, it's weird. Like it's testing your like knowledge. So it says what is the mean of the distribution of sample means. So
Can I see your textbook real quick?
Yeah.
So we're just going back because the mean is the mean is the mean.
Right.
As far as I can tell. That is the
if you look in the textbook, the very first under the 2 rules, like right underneath the lesson outcomes, it says for the mean of draws from a random variable, and then it gives you 2 rules.
Right.
That's basically what it is.
Okay.
Because either way, in the parent population or the sample of means, your mean is the same thing.
Right.
Right. And then you'll need this for the next one.
Okay, number 12. What is the standard deviation of the distribution of the sample mean for all possible samples of size 81 that could be drawn from the parent population? So the standard deviation
is that this one?
Yep.
Yeah.
Yeah, that's the same thing right there. Yep.
Standard deviation. Standard deviation is 7 divided by sample size. 51. Have you guys found a way to like see our quiz more than just one question at a time? Is there a way to do that?
I haven't.
No, I just always scroll.
Okay. Let's see.
Yeah, you just scroll down, but it's not
like a page.
Yeah. I'm nervous.
Welcome back.
Ugh. Do you get
To have your
0.009?
I didn't.
No. What did you plug into the formula?
0.7 divided by 81.
Okay, it's the square root of 81.
So, yeah, there's that. I forgot.
Ugh.
Point 778. No, 0.077.
Yeah.
But is it 3 decimal?
Right.
0.078. Yeah.
Yeah. 0.078. Okay. What is the probability that the mean GPA for 81 randomly selected Idaho students will be less than 3.3? Probability. So we need to use our applet. And
Your X would be 3.3, right?
hey, will you remind me, Shanna, which formula you used for which? For the standard deviation, you use this one, right?
Yeah.
And then what do you use with this one? What's the clue words?
So that one, if you a sample size, if there's no sample size or no n, in that one it'll specifically ask you what's the z-score.
Okay, and then this one is what?
Yeah, if you have n or sample size, yeah.
If it does have n, but you said something about one of them talks about the mean.
Yeah, so that one right there, the X has a bar over it, and that means sample mean. And the formula above that, it has no bar. And that's like when it asks you for an observation or a score or something like that.
Is the one above it.
Right.
This one?
Right, because it doesn't have a bar. Right.
Okay. Back to the question. I'm sorry. What is the probability that 81 randomly selected UAU students will be less than 3.3? So we have to use the z equals the bottom one.
Yeah, so n will be 81.
81.
What did you get right here? Negative 2.571. Yeah, that's right. So you just plugged into the applet wrong.
Oh.
Maybe you didn't put negative or something. You just got the wrong number.
Oh. Me.
This is so weird. Is it 81 minus 3.5?
So it should be 3.3 minus 3.5.
Divided by 0.7 divided by square root of 81?
Yep.
Okay. Is it negative 2.570?
Yep. And then you're going to want to put it in the probability applet.
Oh, yes. Less than 2. Point 0051.
Yep.
Booyah!
I could sing a song. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3? You don't know what they just said?
Yeah, so then we just have to
Highlight the other side of the applet.
the other side of the.
Oh, so instead of greater or less than, it was greater than.
Yep.
Yeah, but make sure you highlight the middle and the other side.
Oh, okay, thank you. I always have a hard time with that part. 9949.
Yeah.
But then we would round to 995.
Yep.
Yeah.
Last question. Uh-oh, it's a hard one.
Last question. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. Standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The mean was determined to be 177. Find the probability that a random sample of passengers will have a weight that is or below the mean than was observed. No more extreme means that we are not.
Sorry, you're going in and out. Okay, so find the probability that the random sample of passengers will have a weight that is as extreme or more extreme than was observed in this sample. As extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours is positive direction. What? Okay, we have the probability word. I know that means we get to use the applet.
So we
And what?
So our U sign is going to be 185. And the X with the bar above it is going to be 177.6.
Okay.
And then our standard deviation is going to be 26.7
Okay.
with a square root of 48.
I have -1920. Put that in the applet. Do we do it on both sides?
Should be the same on both sides. Either one you turn it in.
But to highlight it.
Oh, to highlight.
What is the question asking? Oh, both of them. Yeah. So you would highlight the edges because it's asking for the extreme.
Uh-huh. And I got 0.0549.
Yep. 0.055.
Okay. 0.55. That doesn't seem very extreme.
Yeah.
Okay, we did it. We did it. Hooray. Hey, have fun in Nauvoo. I wish I was going.
Oh, thanks. We're pretty excited.
That is one of my favorite places in the whole world.
We've never been, so it'll be cool.
Oh, how long do you get to be there?
Just the rest of the week. My companion's getting married, so we're going to her wedding.
Oh, that's awesome. You need to spend at least 3 days there. Pretty awesome.
Yeah, it'll be good. We're excited.
So we went, my husband and I went to, they have a records building, and we went and found records from both of our families. You can find if you have family members that used to live there. The coolest part is our families lived like one plot from each other.
Oh my gosh.
So
That's
like
crazy.
our relatives had to have been friends or enemies, I guess. But like their kids would have had to played with my family's relatives. It was really awesome. So
Yeah, that's cool.
okay. Well, are you driving or you're flying?
We're driving.
Okay, be safe.
Thanks.
Thank you so much for your help.
Oh yeah,
Absolutely.
no problem.
I might
We'll see ya.
I might email you if I have any questions on homework, but if you don't get back to me, I understand.
Oh yeah, you can email me. I'll have my phone or Michael's phone, so it'll work.
Okay. Okay, awesome. See you later,
We'll
guys.
see ya.
Okay, bye-bye.